little more practice today. So our first example says 65% of adult Americans are in favor of the death penalty for individuals convicted of murder. In a random sample of 15 adult Americans, what is the probability that Part A, exactly 10, favor the death penalty? So we have different options. We know how to do this by hand now. What is my N on this one? 15. What is my P? Okay. What would my Q be then? Part A, exactly 10, that means X is 10. So if you were doing this by hand, if you look on your formula sheet for the binomial, it says N choose X, so it would be 15 choose 10, which we did on the calculator. P, 0.65 to the X power, 1 minus P, or Q, to the N minus X, so 15 minus 10 is 5. In other words, 10 say yes and 5 say no. And that's not a difficult thing to do by hand, but we've also talked about how we have this table. So let's make sure we can read this from our table as well. Okay, this packet that I gave you Friday, there are actually two tables here. The first two pages are the binomial probability, and the second two, this is your table 4, is the cumulative binomial. And we'll talk about that in just a second. We want table 3, this binomial probability distribution. So my N was what on this example? 15. So that's back of the second page. What was my P? 0.65. And my X was 10. So if you go down, we get 0.2123. Does everybody know how to read that from your table? Make sure you're taking the time to try that.
So when you work it out in your calculator, is that the answer you're going to get?
Yes, so let's confirm that on our calculator.
So this is just a way without using your calculator?
As long as it's one of those common probabilities that are across the top of the chart, you can use the table. If I give you a probability that isn't, you have to do it by hand. So if we use our calculator, we enter first the 15, we go into math, over to probability, and we want the NCR, and then we put in 10. I think yours comes up a little bit different. When you push that button, it says 15 NCR, and then you just type the 10 afterwards, same thing. Close that parenthesis. We have 0.65 to the 10. And 0.35 to the 5th. And so we get 0.2123. So same answer, just two approaches for doing that. Now B, no more than 6. So that means X could be 0 or 1 or 2 or 3 or 4 or 5 or 6, right? So if you were doing it on your calculator, you would have to calculate all 6 of those things and add them together. Looking at our table, we could add my X equals 0, 1, 2, 3, 4, 5, and 6, and that would also work. The other option is to go to table 4, the cumulative distribution. And so what this does is when you look at the 0, it's the same, but when you look at 1, it's the probability of 0 or 1. When you look at 2, it's 0, 1, or 2. It's everything up to that point. So we wanted everything smaller than 6, including my 6. So I go to my N equals 15, X equals 6, my P is 0.65, and we get 0.1132. So that is, am I on 6? All right, sorry, move my finger up one. 0.0422. There is a slight potential for a difference here. If you add up from table 3, the regular binomial. If you add all those, it comes up to be 0.0423, just because every one of those numbers is rounded to 4 decimal places, so there's a little bit more rounding error. This is more exact because they take more decimals and then round ones at the end. But as long as I know where your answer is coming from, it's fine. So there is, depending on if you read it from a table or the cumulative table or on your calculator, your last digit could be different, but other than that, it should be the same.
Where'd you find that 0.0422?
We are on the cumulative table. And this is 15, my x is 6, and it's 2.65. Any other questions? So cumulative table is not something you ever have to use, but it can save you some time. All right. Is everybody okay with that? All right. We have graphed, and I think there's one homework question where it asks you to find the probability distribution. So if I ask you to create the probability distribution, that's when you just list your x and your p of x. We also did some graphing in section 6.1, so I figured this was probably a good option to help us review some of those things from 6.1. If my n equals 8, then if I asked you to make the probability distribution, x would have to be everything from 0 to 8. So probability distribution is just listing every possible outcome and its probability. What should all those probabilities add up to? 1. Okay, if p is 0.15, is that one we have on our table? Yes. Do I want to use my cumulative or my regular table? Regular. And n equals 8, so that's the back of the first page. P equals 0.15, so I don't even have to calculate this by hand. So I didn't ask for it, but if I had said create the probability distribution, you would just be listing this. I'm just copying those numbers down. Does everybody know where I'm getting those? So when I asked you to graph these, we made a pretty informal little graph. You notice when you get down to 7 and 8 here, it says, has a bunch of zeros and a plus. This probability isn't truly 0. It is some positive number, but the first 4 digits are all zeros. So it's just extremely, extremely small. When I ask you to graph this, so your x's are down here, your p of x is here. Let's see, my biggest probability is about 0.4, so I'm going to go up by 0.05. Alright, so then if I were to graph this, at 0 the probability is 0.27. So remember we just put a dot and drew a vertical line going up to that. At 1 my probability was 0.38. 2 was 0.23. 3.08. 4 is 0.01. 0.002. Oh, I got off one, didn't I? you the shape of this, which way is it skewed? Okay. So if I asked you to create or graph a probability distribution, could you guys do that for me? And describe the shape of it? Do we need to do another one, or are we good with that? Okay. Last, only slightly new thing that we're talking about today. This is going to come up more in the next chapter. This is the first time we're going to see this. But in general, if n times p times 1 minus p, or n times p times q, if that is greater than or equal to 10, then your distribution is approximately bell-shaped. So this is something that we could use to see if our data would be bell-shaped before we actually draw the whole graph out. It's kind of a shortcut that we can use. If it's bell-shaped, then the empirical rule applies. And that's on our formula sheet. We've done the empirical rule before. And it told you that 95% of your data would fall within 2 standard deviations of the mean. So if I ask you if something is unusual, that means the probability is less than 5%. So anything that doesn't fall within that 2 standard deviations would be unusual. So if you don't want to write all this down, kind of our concise definition. So if the data is bell-shaped, anything more than 2 standard deviations from the mean is unusual. Again, we know to find unusual, you could really just find the probability and see if it's less than 5%, but this just kind of gives us a threshold. So I'd like to look at one example of this. Okay. So this was an example we were using on Friday. 35% of all households have 3 or more cars. A researcher believes that the percentage is higher. So he takes a simple random sample of 400 car-owning households and found that 162 had 3 or more cars. Is this unusual? So we looked at this example on Friday and we found the mean and standard deviation, but we could quickly calculate that again. If you look at your formula sheet, to find the mean of a binomial, it's just n times p. So there are 400 cars, the probability was 0.35, and that gives us what?
140.
Okay. Our standard deviation is the square root of n times p times q, or 1 minus p. So that would be the square root of 400 times 0.35 times 0.65, and we get
1.54.
Okay. Let's do a quick check. If I do my n times p times 1 minus p, so 400 times 0.35 times 0.65, do you get something bigger than 10? So that means it's bell-shaped. So if n times p times 1 minus p is bigger than 10, it's bell-shaped, which means we could use the empirical rule here. That's what we were just saying on our last slide. So if we wanted to find everything within 2 standard deviations, we need the mean minus 2 standard deviations and the mean plus 2 standard deviations. Okay, so my mean is 140 minus 2 times the 9.54, and what does that give us?
120.92.
Alright, and if I do 140 plus 2 times 9.54, we get?
159.08.
That means 95% of our data should fall between these two values. So would it be unusual to have a 162?
Yes.
Yes, because it doesn't fall between these. So 162 isn't between which means it is unusual. There are different ways of doing that. We could have just found the probability of that and looked at it that way, but this is just kind of restating or showing by example what I was saying on that last slide. Again, this is going to come into play more in chapter 7 when we get there. We're just kind of getting a taste for it right now. Alright, any questions there? Yes?
Wait, no.
That's really all of this section. I do have some extra review slides. Do you guys want to go over that? Just kind of refreshing some of the stuff from chapter 6. Do you want to do a little bit of that review? Yes, no? It's up to you. Might as well. We'll do a few. We don't have to do all of them. Let's do this one. So this was from section 6.1. When I asked you to find mean and variance and standard deviation from a probability distribution. So this one is not binomial. I just gave you a probability formula. What would you have to do here? We do have a test coming up this week, so let's make sure we all are paying attention. What should we do?
Make a table.
I'll just put
My x's are 1, 2, 3, and 4. So if I plug in 1, I get 4 over 10, so 0.4. If I put in a 2, I get 3 over 10, so 0.3. 3 gives me 2 over 10, so 0.2. 4 gives me 1 over 10, which is 0.1. If it's a probability distribution, all of these have to be between 0 and 1, which they are, and they have to add up to 1, which they do. Then, look at your formula sheet real quick. The very first thing under chapter 6 is the mean, or it might also be called expected value, is the sum of x times p of x. So we need our x, p of x. So 1 times 0.4 is 0.4. 2 times 0.3 is 0.6. 3 times 0.2 is 0.6. 4 times 0.1 is 0.4. So the mean, you just add up all of those and you get 2. Everybody understand how I got that? Standard deviation, if you look on that formula sheet, it gives us 2 different options. We typically went with the second one. So it's the square root of the sum of x squared p of x's. So 1 squared is 1 times 0.4 is 0.4. 2 squared is 4 times 0.3 is 1.2. 3 squared is 9 times 0.2 is 1.8. 4 squared is 16 times 0.1 is 1.6. So if you add all those up, we get 5 mean squared. So I get the square root of 1, which is 1. If I ask for variance, that's just your standard deviation squared. So 1 squared, which is 1. So in the beginning, we started out creating these probability distributions, finding the mean, standard deviation by hand. Okay, let's also review how we might do that on the calculator. So I'm going to give us another one. We're going to do this one on the calculator. Everybody needs to grab one. Alright, so I gave you the x and the p of x. You're going to go to your list. Your x's are your L1, and your p of x's are your L2. So then we went to stat, calculate, one variable statistics. Even though we have things in both lists, we want one variable statistics. Now, in general, if you just had one variable, when we first did this, it would have just said list is L1, frequency list would be blank. But our frequency list should be our probability. So we want the list to be L1, the frequency list to be L2. If you need to enter that, you just hit second and the number 2, and that puts an L2 there. And then if you just enter through, it gives you the x bar, that's your mean, and your standard deviation is your sigma. Okay, does everybody understand how to get to those things? So when you do it on the calculator for a probability distribution, your frequency list is the probabilities, the L2s. Okay. Yes.
I got something different,
Did I mistype something in my?
but also it might be because like mine's different.
Yeah,
Remember?
I got something.
But I think I did it how you told me to.
I probably just mistyped something, honestly. Yep, I did. I put 0.008 instead of 0.088. Alright, is that better? Okay, thank you. Alright, that was the stuff from section 6.1. Section 6.2 is the binomial, either using the formula or the table. Do you want me to do an example of either of those? Maybe we could do a couple quick examples and then we'll give you guys time to work. Okay, let's just practice doing one by hand and one on the table. So here I gave you, not even a scenario, I just gave you the variables. If you're looking on your formula sheet, you don't have to memorize the formula. It's right there, binomial probability distribution. In choose x, so 6 choose 4. P, so 0.33 to the x, so to the 4th. 1 minus p, so 1 minus 0.33 would be 0.67 to the n minus x. 6 minus 4 is 2. Does everybody know where I got those numbers from? It's just plugging into our formula. Then start with parentheses 6. You go to stat, probability, and NCR. So 6 choose 4. 0.33 to the 4th. cumulative here because we're just finding one scenario, so you're on table 3. Your n is 10, so that's the back of the first page. P is 0.7, and my x is 8. And if you're reading that from your table, you should get 0.2335. Did everybody find that on your table? Making sure we all understand how to read this table.
How'd you get that again?
Okay, I went to my n equals 10, so that's the bottom of that page. We're on regular distribution. N is 10. Probability is 0.7, so we're looking in this column. And x was 8.
Oh, okay. Thank you.
Alright. Do we need any more with these? So why don't you guys spend the rest of class, you have an assignment, so work on that assignment, it is due tomorrow. This is the assignment I gave you on Friday. And same rules as we've been using this whole